Hello, I'm Jared Skeens, and welcome to the Zoom room. Today, we would like to look at Pure Maths 1 Quadratics, Part 7, the Discriminant. This is going to be an exciting lesson. For one, it's kind of the, at least I feel, it's kind of the crown jewel of the Cambridge question types for the Quadratics unit. They really like to take this particular concept and really come up with a lot of different ways of asking the question. Sometimes it's pretty straightforward, start to finish through the procedure. Sometimes it's just showing and you only go part way. And sometimes they even like to mix it up with a few other question types and splice it together. So you really have to be sharp and on your toes when it comes to this particular question type. And like I said, it's kind of their crown jewel. They really test to see if you understand the quadratics concepts that you've learned. And a lot of those things are tied together with this particular question type. The other reason why I'm excited is because we want to explore our two methods that we learned back in, I believe it was part 3 of our series, where we looked at the quadratic formula and we also looked at the magic potion method. So we will also explore how both of those can be used to solve this particular question type. Now, let's remind ourselves, because I did mention this back in the part 3 of our series, that the quadratic formula does have that, and here's our quadratic formula. It does have this very important feature right here. The b squared minus 4ac is called the discriminant. And what it does, if you remember, I kind of hinted at it, the word to the discriminant obviously comes from to discriminate. And unfortunately, our society has turned that word into a negatively loaded word. Technically, it's a neutral word, just means to separate. That's all it means. But when that separation is used by one group to oppress or look down on or be biased against another group, then that's when it becomes negative. So that's an unfortunate aspect of our society today. But it simply means to separate out. And like I mentioned before, we actually do this in a neutral way in society that's not in a negative way, like when you're in a public place and you go to the restroom. Men go to the men's restroom, women go to the women's restroom. That's a discrimination that is neutral. You know, one's not looking down or oppressing, the other. But generally, because the word has become so negative, we don't even use the word in its neutral meaning because of all the negative attention that it gets. But in math, it has been used to help us understand categories or to separate out for us a number of solutions. This is crucial to understanding when you use this. Anytime your question type is not asking you to actually solve for the solution, but has something to do with the number of solutions, that's when you know you're using the discriminant or possibly could be using the discriminant. Okay, so you really have to read these questions carefully because just the wording of the questions can help you understand what you're supposed to do. Okay, so what the discriminant separates is the number of solutions from your quadratic. We know that a quadratic has an x squared term in it, meaning we should end up with 2 solutions. So what we find out is when our b squared minus 4ac is greater than 0, meaning it's positive, and you have a positive number inside your radical, and you square root a positive number, you're going to get 2 values, a plus and a minus. So if you take this initial starting point, which remember when we talked about it, this is your vertex, and you go right from the vertex and you go left from the vertex, you're going to end up with 2 real solutions. Okay? If this b squared minus 4ac equals to 0, and you square root 0, you still get 0, meaning you're not adding or subtracting anything to your x coordinate of your vertex. What that means is your vertex is on the x-axis. And so you only get one real solution because your graph is only touching the x-axis in one place. Now, if that equation happened to be factorable, what you end up with is a perfect square. So in other words, the factor is duplicated, or it's twice. And so you really need to be careful of the wording. There's a lot of terminology that can be used to describe that. It can be called a double root, a repeated root. It could be, say, I forget exact wording, but that double root, united root, there's all sorts of different ways of saying it where the meaning is that there's only one value from it. So it means the factors are identical. It still counts as twice, but because it's the same number for both, we only end up with one real solution. So if our b squared minus 4ac is less than 0, that means we're going to get a negative. And of course, if you try to take the square root of a negative, you get syntax error on your calculator. And so what this means is that there are no real roots. And what no real roots means is that, one, there are actually 2 imaginary roots, which you won't learn until later in complex numbers, and that's pure mass 3. So you don't even need to worry about that for pure mass 1. And what it also means, more importantly for quadratics, is that your graph does not cross the x-axis. There's no place where your graph crosses the x-axis. And so this b squared minus 4ac is what separates out our possibilities with regard to number of solutions. So it's important to correlate greater than 0 with 2 real roots, equal to 0, 1 real root, less than 0, no real roots. Okay? Now, if we're looking at it from the magic potion perspective, here is our formula for that. So the equivalent of, or I should say, the similarity as far as a discriminant goes, is going to be the z squared. When you apply this out, you're going to get a z squared in your working. And when you solve for the z squared, at that point, that is the equivalent concept as the b squared minus 4ac. The z squared will function as our discriminant. Now, if you compare the numeric values, they will actually be different. But the issue with the discriminant is not the numeric number that you arrive at. The issue is whether that number is positive, 0, or negative. So what we find out in the magic potion method is that the value of this z squared will function in the same way, not in the numeric equivalent value, but in the fact that it will either be positive, 0, or negative. And that's what's important about the discriminant, not the exact number of the value. Of course, it is going to have a numeric value, but it's more for interpretation than it is, at least up front. When we get into the solving of it, you're going to find out that even though the z squared and the b squared minus 4ac actually have a different numeric value, when you work it out, we're going to get the same answer. And that is what is nice about mathematics, is that you can model reality in different ways and still have an accurate understanding of what's going on. That's the beauty of mathematics. So we're going to look at these two different models, and we're going to start applying it to our Cambridge question types. Now, they don't come right out and give you a nice quadratic, and they don't make it completely easy by saying 2 real roots, 1 real root, no real roots. They use English wording that you need to determine the meaning of those words with respect to the system. So here is an example. We're going to work through several examples so that you can get a hang of it. It's really important. This is a major question type that Cambridge uses for quadratics. It really tests your understanding of the whole quadratic system. So here they give something, y equals 2x plus 12 over x. Right away, you're going to panic because this looks nothing like a quadratic, doesn't look like anything that maybe you've worked with, and you don't even know what to classify it. It's not linear, it doesn't look quadratic, and it's just called a curve, okay? Then you have this y plus x equals k. Now, even though it's not in the right order, you should recognize this as a line because your x is to the 1 power. You can subtract the x to the other side to make it follow the y equals mx plus c format. So even though it's not in the right order, you still should recognize that as a linear function. This we don't recognize, and it doesn't really matter at this point. So what we see in the instructions, and I've kind of modified it a little bit to fit on the board. What we want to do is find the set of values. Remember, I said when you see this word set of values, that is your clue that you're working with inequalities. So you're either going to have like a quadratic inequality, or you're going to be working off the discriminant because the discriminant has inequalities. Of course, if we're working with the discriminant, means we're probably going to end up with a quadratic inequality anyway, and that gives us a chance to review what we covered in part 6. Okay, so set of values means you're dealing with inequalities, and it's of our letter K, which we want to look for here. Now, here is our clue. The line, which is this one here, does not meet our curve. So this one is a curve, which we don't really recognize. This one is the line. They do not meet. So if they don't meet, it means there's no solution. And if there's no solution, that's the same thing as saying there are no real roots, because if there was a real root, there would be a solution. So you need to equate not meet or no solution with no real roots. So if we're going to do it with the quadratic formula method, we'll pick the b squared minus 4ac. If we're going to use the magic potion method, we're going to have to find the z squared. So first, before we choose a method, what we need to do is we need to take these two equations and we need to do something with them. Even though it says find the values at which they do not meet, we are going to set them equal to each other anyway. So we're going to take, if this one did happen to meet this one, then that means our y1 would equal y2, at least for the coordinate or coordinates at which they intersect. So even if it says do not meet, we're still going to set it up as if they did. Right? So what we're going to have to do, set y1 equal to y2. But before we do that, we need to get our y2 by itself. So y2 would equal a negative x plus k. So here we're in our linear format, y equals mx plus c format. And so now it looks like a line at y1. We want to set it equal to y2. So we have 2x plus 12 over x equals a negative x plus k. So we've eliminated the y's. Okay, now that looks a little better, but at least the y's are gone. But now we have this fraction here. We don't like fractions in our equations, so we're going to multiply everything by x to eliminate our fraction. And we're going to end up with 2x squared. The x's cancel here, so it's just plus 12, equals a negative x squared plus kx. Well, now we see our quadratic showing up, but it's not in the proper order. And we know when we're working with quadratics, we want everything on one side set equal to 0. So we're going to move these two to the other side. So we're going to add x squared, and so that gives us 3x squared plus 12 equals kx. Now we need to move that to the other side. So minus kx. Notice this term is not like terms with either of these. Be careful that you don't combine it in an incorrect way. Always, with algebra, you're always dealing with terms. Like terms, it's like your place values in digits in basic math. So we end up with 3x squared minus kx plus 12 equals 0. Now we have our quadratic equation, right? But we still have two variables. We have x and we have k. So the beauty of using the discriminant is it only uses the coefficients of the quadratic equation, and it eliminates the x variable. See, the goal is not to solve for the value of x. We're not solving the equation. What we're doing is we're finding the value of our coefficient that allows this equation to meet a particular criteria with, in this case, that won't allow the curve and the line to intersect. So it really tests your conceptual understanding of quadratics more than simply just following a procedure to solve something, as far as like solving the value of x, which we normally do. Now that we have this, now we have our two methods from which we can choose. I'll demonstrate both. You're going to have to decide which one you prefer. And there might be times where you choose one over the other, but it's good for you to at least be aware of how they both work. Now, we're going to start with the quadratic formula. It's the one that most people, or at least have been exposed to before you get to A-level math. You've already had it in IGCSE math. So we're going to start with this first. Because we do not want them to meet, we do not want to have any solutions. That means we want to use the b squared minus 4ac equal to 0. So we're going to use this one here. So the b is the negative k. Here's our a, b, c. A is 3, b is negative k. Remember, the sign goes with the coefficient, and c is 12. So we end up with a negative k squared minus 4 times 3 for a c times 12, and this needs to be less than 0 in order for this to be true. So we end up with k squared. Now remember, exponents distribute to signs and letters. So a negative squared becomes positive. K squared minus 3 times 4 is 12. 12 times 12 is 144. And this needs to be less than 0. So k squared is less than 144. We add the 144 to the other side. And then, now here's a tricky part with quadratics and inequalities. We didn't run into this in part 6 when we talked about quadratics and inequalities. But here we see where we're square rooting on both sides of our inequality. And when we do that, remember, a square root produces a plus and a minus. Also, hopefully, at some point, when you learned your math, you learned that add and subtract is that first layer of operations, the most basic layer, adding and subtracting. They're opposites, one layer. The next layer is multiply and divide. Multiply is a fast way of adding. Dividing is a fast way of subtracting. You're subtracting by groups, you're adding by groups. So multiply and divide distribute to add and subtract. Your third layer are your radicals and exponents. Radicals and exponents are a fast way of multiplying and dividing, okay? Think about it. Your power, your exponent is saying you're multiplying the same thing over and over again so many times. So when you're doing a radical, it's actually a fast way of dividing. And because you end up with a negative in your plus and minus, that's going to flip the inequality for the negative part. So when we get what we would think of as getting a plus or minus 12, we need to be careful with that. So here we get the cancellation. So k is going to be less than, we keep the inequality, the positive one, 12, or k will be greater than negative 12. It flips the inequality. And notice that these are together. So actually this should be an and. If you needed to draw a little graph on it, I'll just put it over here real quick. You'd have 12 and negative 12, and you're saying that k is less than 12, but at the same time, it's greater than negative 12. That means we can write this as one statement. This is an and statement. So more correctly, this will be written as this. And we do not want the equal sign because the equal sign would imply that it does intersect at one point. So we do not want the equal sign in our inequality. You're going to have to kind of think about the meaning of the equal to part, because we do not have an inequality to look back to for this. So you need to look at the meaning of the inequality and the equal in our concept. So this then would be our answer set for this, doing it with this method. Well, what if we used the magic potion method? What is that going to look like? Well, we still come to this part here, and we need to figure out what the z squared is. So if we take the opposite of b, the opposite of a negative k is k over, oh, notice we have our 3 here. We need to, at least the way I explained it, we can put our a here, or we can divide it through. If we divide it through so that we don't need to worry about the a, then it becomes k over 3x plus 4 equals 0. So when I use the magic potion method, I don't like having all the extra A's in the formula. It makes it harder to remember. I do have to remember to divide the A through first. So with the quadratic formula, it just uses the A in place. I chose not to include the A in the formula. To me, it just looks more complicated that way. But it would work if you put the A here, here, and here, like I showed back in part 3B, I believe it was. Okay, so I've gotten rid of the A because I don't have it in my formula. So this would be the opposite of the B is K over 3 divided by 2 means we have K over 6. Remember, the 2 just multiplies into the denominator. So dividing by 2 is the same thing as multiplying by 1/2. So we get K over 6 plus Z, K over 6 minus Z equals, and the C is 4. So that means we get a K squared over 36 minus Z squared equals 4. So Z squared, when we add that to the other side, okay, our Z squared and subtract the 4 equals K squared over 36 minus 4. I hope you can follow what I did. So this times this is K squared, 6 times 6 is 36. Remember, you don't have to do the nose and mouth. This is a difference of squares that cancel out. Z times negative Z is negative Z squared. Here is our C. Add Z squared to the other side and subtract the 4. So you get K squared over 36 minus 4. That's our Z squared. This is our discriminant for the magic potion method. So this is what we want to take and make less than 0. So if we add 4 to the other side, oops, sorry, add 4 to the other side, and then multiply by 36, guess what? You end up with 144 again. And we end up right back where we were over here. You square root both sides. You're going to get your plus or minus 12. So K is less than our 12. The negative flips the inequality and makes it from the, remember, you read an inequality from the variable. You don't read it by the direction it's facing. You read it from the variable. So K greater than negative 12. Okay, so K is less than 12, and at the same time, K is greater than negative 12. Again, we get the same answer with a little bit different method to it. So as much as I like the magic potion for solving quadratic equations, I do feel like the B squared minus 4AC discriminant is just a little bit more straightforward and easier to use for this particular question type. But I still really like this new alternative to the quadratic formula. It does do everything that the quadratic formula does. You just have to get used to how it works, which most of you at this point have not been introduced to that back in IGCSE material because it wasn't around then. It just came out in 2019. So this is our first example. Let me set up for the next example. Okay, here we're back with our second example, and this time we have something that actually looks like a quadratic. Y equals 2x squared minus 3x plus 1. So we have a quadratic equation here. And then here, over here we have y equals kx plus k squared. Again, you should recognize this as linear. Even though the k has a squared, the k in this example is a constant, meaning that's just a number. There's no variable there. The variable is the x, which has an understood 1 as the exponent. So here's our y equals mx plus k squared. This is actually linear. Now, this is a show problem. So there's a little twist on this. It says show for all values of k that the curve and line meet. Well, now it's not saying a set of values, so we're not actually solving for what the values of k are. We now have to show that all of these values satisfy this criteria. So that sounds a little strange, and I don't want to spoil it right now with a hint, but you're going to see these kind of show type questions that involve all or nothing type questions will come up in the future. So I'll wait till we get to it. I don't want to give you a hint right now. So as you're reading this, it might not make sense, and that's okay. What we want to focus on is this right here. The curve and the line meet. Well, it's not telling us how many times it meets. It just says it meets, meaning that it could be once, that classifies as meeting, and it could also be twice. That would also classify as meeting. It cannot be no real, because no real does not meet. So we eliminate this b squared minus 4ac being less than 0. We're eliminating the less than 0 possibility. It can be either the equal 0 or the greater than 0. Both of those qualify with this word meet. So we need to combine our inequality with the equal part in this particular question. So we're going to start off with, again, we have to go back. If they meet, then that means our y1 equals y2, that our one equation is actually intersecting the other equation. So if we set these equal to each other, we get 2x squared minus 3x plus 1 is equal to kx plus k squared. Okay? Now we want to get everything on one side and set it equal to 0. So we're going to subtract the kx and we're going to subtract the k squared, and we're going to put them in order according to their like terms. So here we have a 2x squared minus the 3x. This is also an x, so minus kx, and then we have a plus 1 and our minus k squared equals 0. If you want to put it on both sides so that you can see that we've kept our equality here. Here's our boundary line. We did the same thing from both sides, and we line them up by like terms. That's important when you're working in algebra. Now we want to combine our like terms by factoring what is common here. So we have 2x squared. We're going to factor out that x. And so what we end up with, and we can also factor out the negative so that we get 3 plus k. So we're going to factor out the negative to the front, have 3 plus k in the middle, and factor out the x to the back. Really try to understand that. It's an important skill that you need to develop, is understanding how you can make this one term or one coefficient for x. So here's our x. This is the coefficient. The sign is either positive or negative, and you factor that to the front. So now it's term by term. Remember, terms are not separated by multiplication. They're separated by add and subtract. Same thing over here. We're going to just put this in parentheses so that this becomes one unit representing our constant. So here's our A. Our A is the 2. Our B is the negative parenthesis 3 plus k. And then our C is the 1 minus k squared. So if we use this in our quadratic formula method, what we're going to do is we're going to say our b squared. So this is going to be a negative 3 plus k squared minus 4ac is greater than or equal to 0. The greater than works, the equal to also works. So we need both. Now we multiply this out. This is just binomial expansion. You don't have to worry about the negative. The negative squared becomes positive. It goes away. So we have 3 plus k squared. Hopefully by now, if you're in A-level math, you can multiply that out in your head. If you need to do it on a scratch paper on the side, go ahead. But you should be proficient at your multiplication of binomials by now. So you get 9 plus 6k plus k squared. Here we have 2 times 4 and a negative. That's a negative 8 that needs to distribute through this parenthesis. So we end up with a negative 8 plus 8k squared greater than or equal to 0. When we combine like terms, 8 and 1 make 9k squared plus 6k, 9 minus 8 plus 1 greater than or equal to 0. Now, like I said before, when you're dealing with quadratic inequalities, high % chance that this can factor. So that takes you back to part 1 when we talked about factoring quadratics. This happens to be a perfect square. The factors of 9 and 1, factors of 1 are 1 and 1, factors of 9 are 1, 9, 3, and 3, that add up to 6. Well, 1 times 3 and 1 times 3, 3 and 3 add up to 6. So that's our combination that gives us 6. So we have a 3k plus 1 times 3k plus 1 greater than or equal to 0. We're going to take advantage of the fact that this is a perfect square, and we're going to write it as 3k plus 1 squared greater than or equal to 0. Now remember, we're not solving for k. All we're doing is demonstrating that for all values of k, the curve and the line will meet. So one of the advantages of ending up with a perfect square, whether you do it through factoring or whether you did it through, say, the complete the square method, these are things that you're going to have to keep in your mind as you move forward through the Peer 1 math book. There's going to be these places where they ask you to show that all or nothing, or it's always positive or always negative. You're going to see that all word in there, and it's going to be connected to a perfect square. How does that help us? Well, no matter what value you get in this parenthesis, meaning all values of k that you plug in here, you're going to get a value in this parenthesis. And when you square it, no matter what that value is, anything squared is positive. Positives squared are positives, and negatives squared are positive. So this will, what you're going to say here is, therefore, always positive, thus greater than or equal to 0. That's one way of stating it. You don't have to use my words exactly. What Cambridge is looking for is that you're interpreting this perfect square as always ending up with a positive value, and if it's positive, it's greater than or equal to 0. So there's maybe different English words that you could use to imply that, but you need to imply somehow with your words that that's the interpretation of what you're looking at here in this algebraic statement, okay? So that's how you would do it here. This looks a little scary about the magic potion method, but I'm going to give it a shot because that's part of exploring mathematics, is to see how it works. But first I need to divide that a through. So we're going to end up with x squared minus a 3 plus k over 2 x plus a 1 minus k squared equals 0. So we divided 2 through everything. Looks a little ugly, but don't be afraid of fractions. It's just a multiplication and a division in one location. Okay? So we come up to this. We take the opposite of b, so that gets rid of the negative. That's nice. And we divide by 2 means you multiply 2 in the denominator. So we get a 3 plus k over 4 plus z, 3 plus k over 4 minus z equals, our c is this, and I didn't give myself a lot of room here, 1 minus k squared all over 2. That's our c value. So when we multiply this out, here we have 3 plus k squared like we had over here. We get our 9 plus 6k plus k squared all over 16 minus z squared equals our 1 minus k squared all over 2. Okay? So if we solve for the z squared, we add it to the other side and subtract this. This is going to equal 9 plus 6k plus k squared all over 16 minus. Now, to get a common denominator, we need to multiply by 8. So to get this over 16, we're going to put this as 8 minus 8k squared over 16. We didn't have to, but I like to have common denominator. Now, our z squared is our discriminant. It's what separates out our possibilities. So this has to be greater than or equal to 0. Okay, so I'm just going to put that over here so that I don't have to rewrite this. We're replacing the z squared and saying that all of this has to be greater than or equal to 0. That's the meaning of our z squared, that we want to be this or this, greater than or equal to 0, because we want to have solutions. We want the graphs to meet. So obviously the first thing we're going to do is get rid of this fraction. We're going to multiply that 16 through. In fact, the more that you work with the magic potion, you can find shortcuts to simplify it. If you already know that you're going to be dealing with a 0 on the right-hand side, then that means your fractions are going to disappear anyway. The only thing you want to be careful with is that you don't eliminate the fractions too early. So you might have to work with them until you get to the point where you know you can eliminate them. But it will simplify things down. Multiply everything by 16 and your fraction goes away. And now notice you get 9 plus 6k plus k squared. Don't forget to distribute the negative. Minus 8 plus 8k squared greater than or equal to 0. Now find your like terms. We still end up with 9k squared plus 6k plus 1 greater than or equal to 0, which is what we had over here. And we end up with our 3k plus 1 squared greater than or equal to 0. We end up at the same place. That's what's beautiful about math. You can model reality in different ways and get the same thing. Math is not just doing problems, it's learning how to model reality. And this method is purely algebraic, coming from completing the square. This one is a little bit more graphical, visual, using that midpoint and the symmetry. They're both equally valid ways of modeling a reality, and they both work. That's what's wonderful about mathematics. So we end up with the same conclusion. Perfect square is always positive, thus greater than or equal to 0. I do have to admit again that even in this example, the quadratic formula, or the b squared minus 4ac, is a little bit easier to use. We didn't have any fractions over here. We did end up with fractions over here. For some students, that's really going to turn you off to the fractions. So I don't blame you if for the discriminant you use the quadratic formula or the b squared minus 4ac in this particular question type. But please don't give up on the magic potion. It's got some really nice qualities to it, and hopefully it will help develop your appreciation of mathematics. So let me set up for another one, and we'll, I think in the next examples, to save time, I'm only going to use the discriminant, the b squared minus 4ac, because we've seen twice now that it's a little bit easier than the magic potion way, and that way it doesn't take us quite so long. Okay, we're back with our third example, and I'll try to go a little bit faster. Now that you've seen two examples, I don't want to just keep re-explaining everything, so I'll go a little bit faster, and also for the sake of time, I will not do the magic potion method as much as I really appreciate this new mathematical development. I will stick to the b squared minus 4ac, as we've already seen that it does seem to be a little bit more direct for this particular question type. So here we have a quadratic, y equals 2x squared minus 6x plus 5. Here we obviously have a line, y equals 2x plus k. It says to find the value singular of k. Notice not set of values, so we're not dealing with the inequalities. The line is tangent to the curve. Notice we have a new word here, tangent. You need to remember that this is not your trigonometric tangent. This is a geometric tangent, meaning that you have a curve and a line, and tangent means it only touches at one point. So if you have a curve and a line that's tangent, they meet or touch at one point. So this is our one real solution. So that's where our b squared minus 4ac equals 0. So again, value singular, tangent, there's one. That's your clue. So we want to show where y1 is equal to y2. So 2x squared minus 6x plus 5 is equal to 2x plus k. We want to move it all over to the right-hand side. So important to show your work. We're going to subtract 2x from both sides. Keep it in like term. Subtract k, that's a constant, meaning it's a number that goes in this column. So we end up with 2x squared minus 8x plus a 5 minus k. We put that in parentheses for a constant, equals 0, because these have canceled out. So now we have our ABC. We're going to use our discriminant where b squared minus 4ac equals to 0 because it's tangent 1 point. So our b squared, here's our negative 8 squared minus 4a, c, 5 minus k, that's our c value, equals 0. We get 64 minus, this is an 8, so a negative 8 being distributed gives us a negative 40 plus 8k. So be careful with this distribution of the negative. A lot of people will do 2 times 4 is 8, or they only distribute the negative to the front term but not to the back term. So that's careful with your signs. Equals 0. So we end up with 64 minus 40 is 24 plus 8k equals 0. 8k equals a negative 24, and k equals a negative 3. Okay, so I think at some point I told you to be careful and show your method and your result. I did skip a little bit of my method and just went from result to result, but I hope that you will be able to follow that. You should in good math form, show your step what you're doing. I'm hoping that at this point, it's simple enough that you can follow my method from result line to result line. But our answer is k equals -3, and that one was a little bit easier, but all of it hinges on your interpretation of the English words. You have to understand language communicates not only in the English words, but in math. Math is a language that communicates as well, so all the details are important. Set up for one final example, and hopefully you will become better with this discriminant. Okay, here we are back with our final example, and it's, again, these questions can be asked in a lot of different ways, so it's hard to kind of include every little variation of it in the examples, but I hope at least through the 4 examples that we're going through in this video, that at least gives you enough of an idea of what you should be looking for, and then you can apply it and be successful in this question type. So here we have obviously a line, y equals 2x minus k. We have this quadratic, y equals x squared plus kx minus 2. Again, find the set of values. So that's our clue that we're dealing with an inequality. And our line meets the curve at 2 distinct points. That means we're looking for 2 real solutions, which is our b squared minus 4ac is greater than 0. So we're going to do that. And again, we want to look at where does y1 intersect y2. So 2x minus k equals x squared plus kx minus 2. Again, we want to move everything over in the side that allows our x squared to be positive, just makes it easier to think through. Minus 2x, keeping our like terms, plus k plus k. So here we're keeping our equality. So that gives us a total of x squared. Again, we're going to notice the k is positive, so I'm going to put that first. K minus 2, that way I don't have to factor out a negative in the front. X, so we factor the x out, so we have a shared coefficient here in our like term, or a combined coefficient. And then also we want to keep this together, and since the k is positive, I'll again put the k first. Generally, it's nicer to have the positive in front. And this equals 0. Now that we have our quadratic laid out here, we're going to use the discriminant, and we want to have 2 real roots or 2 distinct points. Again, you notice how the English words correlate with our number of solutions. That's the important thing in this concept, is the number of solutions. So we use our b squared. So we have a k minus 2 squared minus 4. A is an understood 1. C, and we want greater than 0. Remember, you're not using the equal 0. We're not solving for x. We are solving for a value of k that fits this criteria. And now we multiply this out. We get k squared minus 4k plus 4. Here's a minus 4 that distributes. So minus 4k plus 8 greater than 0. So we have k squared, a minus 4k, and a minus 4k is a minus 8k. A plus 4 and a plus 8 is a plus 12, greater than 0. Great, now we get to practice our quadratic inequalities again, like we did in part 6 of our series. So we factor this. The factors of 12 are 1 and 12, 2 and 6, and 3 and 4. And they have to add up to a negative 8. That means we want a negative 2 and a negative 6 add up to negative 8. So that gives us k minus 2, k minus 6 is greater than 0. Of course, we want to double check just to make sure everything's right. K times k is k squared. Negative 2 times negative 6 is positive 12. a negative 2k, and a negative 6k is a negative 8k. So we're doing good on that. Remember, we want to use the zero boundary to help us. Remember, the zero is the boundary between the positives and the negatives. What we're looking for is the greater than zero. We're looking for the positives. So when we solve this, you can see that k minus 2 equals 0, k equals 2, k minus 6 equals 0, k equals 6. So on our number line, we're going to put them in order. We're going to have 2, 6. Those are the zeros. That's where it crosses the x-axis. That's kind of our boundary between the positives and negatives. And this is a positive k squared. That means our this parabola that we're dealing with, or this quadratic that we're dealing with, has a positive k squared in the front, meaning our parabola is going like this. Okay, so make sure you're looking at this one. This is the one you're working with, not with this one up here. Okay, so you look at this one. This is the one that we factored. This one is the one that's facing up. And here is our positive section, negative section, because it's below the x-axis here. This is above it, so that's our positive, meaning the y value, if you're on an xy graph, would be positive or negative. Okay, from your x-axis perspective. So we want the greater than 0. So that means we either want k, which is our variable, less than 2, or k in this direction greater than 6. And that is our answer for this particular question. So I hope that this gives you enough exposure to the various ways that they can ask this question type. It is frequently asked, and you do need to be able to correlate how the words relate to our number of solutions. You need to be able to work through your quadratic procedure, whether it's with inequalities, factoring, solving. All of that gets mixed together in this question type. And so I wish you luck and hope that you're able to be successful. Thank you again for listening and joining me in the Zoom room.